All right, in this video, we're going to look at the intermediate value theorem. Before we go over the theorem itself, let me pose this question to you. What we're looking at is the graph of a continuous function, and I've covered up part of the plot here. I've covered up part of the graph. So we can see on the left of the covered up part, the graph is sloping downwards, and it hits this coordinate, negative 0.5, and somewhere around y equals 2.5. And then to the right of where it's covered up, it hits the coordinate x equals 1.5, and somewhere around y equals negative 4.5. And then after that, it slopes upwards. So the question is, does this graph pass through the x-axis on a part that's been covered up? So keep in mind, this is a continuous function. And if I just kind of highlight where the x-axis is right here. So this is your x-axis. So the question is, if this is a continuous function, do you think the function passes through the x-axis in the part that's covered up? So if you answered yes to that, then you would be correct. So let's reveal what this graph is underneath. So that's our graph, and you can see, since it's continuous, you have to be able to get from this point here to this point here without picking up your pencil. And it could be going up and down, and it could be doing some crazy stuff in between those 2 points, but it has to hit every single y value between these two other y values. So between x equals 0.5, between x equals negative 0.5 and x equals positive 1.5, it has to take on every single y value between about positive 2.5 and negative 4.5. And so since y equals 0, the x-axis is between those two y values, it has to pass through the x-axis. So what we just used to reason through this is actually the intermediate value theorem. So the intermediate value theorem says that if y is equal to f of x is continuous on a closed interval ab, then there exists some x value c such that a is less than c is less than b, and f of c is between f of a and f of b. And I know that's very wordy, but that's literally what we just used. So remember, when you're looking at a theorem in calculus, you want to try to think, well, what is the hypothesis and what is the conclusion? So the hypothesis is the part that comes after the if. So after the if, we have y equals f of x is continuous on a closed interval a and b. So that would just be your hypothesis. And then the conclusion says, the conclusion is after the then. And our conclusion for this has a couple parts. Basically, it says that there exists an x value of c between a and b. And also, f of c has to be between f of a and f of b. So c is between a and b, and f of c is between f of a and f of b. In other words, if y of 0 is between f of a and f of b, then y equals 0 equals f of c for some c on ab. So here's an example. This is just a true-false question. Let's say that f of x is continuous on 3, 10, and assume that f of 3 is equal to 6, and f of 10 is equal to negative 8. Then there must be some c on 3, 10 where f of c is equal to 0. Is this true or is this false? So pause the video for a second and think about it. Okay, did you get an answer? So we know that f of x is continuous on 3 to 10. So that's the hypothesis from the intermediate value theorem. And then let's look at the conclusion part. The conclusion part of the intermediate value theorem says that there exists some x value c such that c is between a and b, and f of c is between f of a and f of b. Well, this is just saying that if you look at the y values here, at f of 3, the y value is 6, at f of 10 is negative 8. So the intermediate value theorem says that there has to be some value c such that f of c, the y value of that, is somewhere between 6 or negative 8. And they're asking you specifically, is there an f of c equal to 0? So just compare the y value for this to the other two y values. 0 is between 6 and negative 8. That means that there has to be some c that is on 310. And c being on 310 just means it has to be between 3 and 10. So the parentheses here just means that c has to be specifically between 3 and 10. It cannot be equal to 3 and 10. So this would be true. Does f of x equals x cubed minus x minus 1 have a 0 between x equals 0 and x equals 2? So if you think you can solve this on your own, go ahead and pause the video and see what you can do. Okay, so in order to use the intermediate value theorem, we have to show that the hypothesis was true. And the hypothesis was that our function is continuous. This doesn't specifically say that the function is continuous, but it does give us the equation itself for the function. So there's something to note here, and I haven't said this yet, but this is something that you want to remember, that all polynomials are continuous. And they're continuous everywhere. So if you have a polynomial, it's also going to be continuous for any segment that you're looking at. So in this problem, our function f of x is a polynomial. And I forgot how to spell polynomial. Polynomial. So f of x is a polynomial. And let's not get too wordy, is a polynomial and is continuous everywhere. And it's very important that you write that if this is an FRQ question on the AP exam, because that would be you checking off the hypothesis. So if you did not write that sentence, you would lose a point. So f of x is a polynomial and is continuous everywhere. So now we have to apply the conclusion part of the intermediate value theorem. So the conclusion part just says that there is some value c between a and b. So our a and b values are here and here. So a is equal to 0, b is equal to 2. Such that f of c is between f of a and f of b. So we don't know what f of a and f of b are, so we need to figure that out. So that would be our next thing we need to do. So f of a would be f of 0. So all I have to do is plug in 0 to the function. So this would be 0 cubed minus 0 minus 1. So f of a, which is f of 0, that's equal to negative 1. And then my f of b would be f of 2, which is 2 cubed minus 2 minus 1. 2 cubed is 8 minus 3. 8 minus 3 is 5. So I've got that. I've got my y values. What it's asking me for here specifically is that it has a 0, and if you didn't remember what 0 means, let's just write that out. So 0 is whenever you're on the x-axis. So this would be like an x-intercept. Or this is whenever y is equal to 0, also called a root. So any of these ways you can refer to what a 0 is. So we're being asked, does this have a 0? So does this have a part where y is equal to 0? And notice that y equals 0 is actually between negative 1 and 5. So we can say, therefore, since 0 is between the two y values we just found, that would be f of 0 and f of 2. IVT says that there will exist a value of c on 0, 2 such that f of c is equal to 0.